Hello everyone. So in this short video, I'll give a lightning review of my poster. So my poster title is Strings from Feynman Diagrams, and these are my collaborators. So let's get into it. So deriving gauge string duality. So what we attempt to do here is to address this problem. Can we make the Thooks insight precise, which was the gauge theory Feynman diagram expansion can be reorganized into a genus expansion of some closed string world sheets. However, the typical examples of gauge string dualities C equal 1 MQM and minimal string 2 matrix model require double scaling. These double scaling limit corresponds to treating Feynman diagram as a discretization of the worldsheet and then taking the continuum limit to get the typical worldsheet behavior. However, this double scaling limit is very different from the Thooft limit we see in most higher dimensional examples of ADS-CFT. We give a precise dictionary between the gauge theory Feynman diagrams and the points on the moduli space of Riemann surfaces while working in the Thooft limit with this simple example of two matrix model, and we make use of stable parameterization to achieve that. So we work with this simple matrix model, these simple observables, and any general correlator can be written as sum over permutations, sum over three permutations, described in terms of sum over three permutations satisfying that their product is identity. And this enables an equivalent description in terms of sum over ramified coverings of sphere. Now to reconstruct the worldsheet from the Feynman diagrams, we make use of this exact equivalence of metrized ribbon graphs with n faces and the decorated moduli sphere genus G Riemann surfaces with n mark points. So we define a unique meromorphic quadratic stable differential on the Riemann surface and associated to it the features of the metrized ribbon graph in this manner, and some special trajectories corresponding to this quadratic differential take the form of metrized ribbon graph, which we will call the stable graph. So our prescription is that this stable graph is related to Feynman diagram by a graph duality, and the lengths assigned to this stable graph edge are the number of big contractions crossed by it, which is always an integer. And because of this fact, we see that these worldsheets are exactly the worldsheets admitting Bailey maps or the holomorphic covering maps of sphere branched over 3 points, which are exactly the ramified coverings of sphere we saw here. And this tells us that there are only certain worldsheets that contribute, and this leads to localization of MGN, which is typical in topological A model. So in this way, we get both the worldsheet and its embedding in natural embedding in target space P1, and there is some ongoing work in that direction as well. Now, another question that we can ask is, can the stable graph be the Feynman diagram itself? And the answer is yes, it can be. And by this dynamic graph duality and degrading in out procedure, we achieve another matrix model whose Feynman diagram is exactly the dual of the original graph, and it is exactly the stable graph we saw earlier. Now, finally, our two matrix model arises as a subsector of the full n equal 4 super Yang-Mills. So, and also that the two matrix model corresponds to tachyon, can capture the tachyon correlators in C equal 1 itself dual radius. So, in a sense, we see our two matrix model capturing full space-time theories being realized as a subsector of full space-time theories in this manner. Thanks.